Welcome to a sim code. Don't miss out on new content. Like this video, subscribe, and turn on notifications to stay updated. In Python, generators are a type of iterable, like lists or tuples, but instead of storing all values in memory at once, they generate values on the fly using the yield keyword. When a function contains a yield statement, it becomes a generator function. When called, the function does not execute immediately but returns a generator object, which can be iterated over. Each time the generator's __next___ method is called, or when used in a loop, it resumes execution from where it left off, allowing it to produce the next value. This approach is memory efficient, especially for large datasets, as it only generates items one at a time instead of holding the entire collection in memory. This example defines a Python generator function count_up_2, which counts from 1 to a specified limit and yields each number one at a time when iterated over. The generator is memory efficient because it produces each number only when needed, rather than generating and storing the entire sequence up front. In the provided example, the generator is called with a limit of 5, and a for loop is used to print each number from 1 to 5 as the generator yields them. The goal is to demonstrate how generators work to produce values on demand, making it a useful technique for handling large datasets or sequences without using up too much memory. This is a generator function called count_up_2. A generator function in Python is defined using the def keyword like a regular function. The key difference is that instead of using return, it uses the yield keyword to produce values one at a time. Limit is a parameter passed to the generator function. Limit is the highest value the generator will count to. It is an integer in type. Count is an integer in type. It represents the current number in the counting sequence. It is used to keep track of the value the generator is currently yielding. The following while loop will continue to execute as long as count is less than or equal to limit. It ensures that we only generate numbers up to the specified limit. This is a logical expression that checks if count is less than or equal to limit. Yield is the key to creating a generator. It produces the current value of count. The function execution pauses here, and count is returned. The next time the generator is called, it resumes from here. After yielding the current number, count is incremented by 1. This ensures that the generator moves to the next number in the sequence on the next iteration. Now, we create an instance of the generator by calling the function with a limit of 5. Counter is a variable that holds the generator object returned by the count_up_to function. Counter is an instance of a generator object. The type of this variable is a generator. The generator object does not execute until it is iterated over. It produces values only on demand. The next part of the code iterates over the generator object using a for loop. The for loop is used to automatically request values from the generator one at a time. Number is a loop variable that will take each yielded value from the generator. The for loop automatically calls next on the generator and fetches the next value yielded by count_up_to. The current value of number, which is each yielded value from the generator, is printed. This process continues until the generator raises a stop iteration exception, for example, when the generator has no more values to yield. Now run our code. That's it for today. Like, comment, and subscribe to stay updated with more content.